So now we're back to our regular session. Study. So once again, if you share my profiles, actually looking for two players, don't need to worry about experience. We have a gap of anyone with no experience having good communication and basic expert. Please share it to me. I'm looking immediately. So now back to our session. So yesterday we were just talking about the basic Hadoop architecture. I started with file system because this HDFS is nothing but a distributed file system. And what is file system? What is the journey in the file system? What is the basic version of the file system? And how we enhance storage capacity with the SAN and network file system, and that is the second generation, but they can help to some extent to improve the storage capacities, but they cannot help you in terms of the data processing, and also they have their own limitation in terms of enhancing the storage capacities, and that is the second generation. And then the current generation, we are talking about the distributed file system. And a distributed file system is a concept like how we actually store the data. But there are many the distributed file systems available in the market, but out of which like Hadoop distributed file system is specially designed with some new concepts and features, that is something like the block sizes, and the very regular file systems will have the minimum file the block size of very limited few kilobytes, and then whereas here it is going to be almost 128 or 64 MB. That is of course configurable, and that helps to when there is a disk scan happening or disk read happening on the disk, at any given point of time, the amount data can be immediately pushed from the disk to the memory. That is the size. So as it is increases, your data scan read also will be improved greatly. And then distributed, rather than keeping the data in one system, in one node or in one disk, and the data, these blocks are getting distributed, so that two ways it will benefit. One is when you are processing the data, you can read the data parallelly from every block separately, and by utilizing the hardware resources of that particular node. And also, when you are processing the data, in case of any disturbance and the missing the nodes due to some failure, then you'll also have a replication for every particular block which is created, and that way always your data is available. So high availability is provided with the replication, and it also supports commodity because we don't need any rules and regulations, or we don't have any strict rules to follow or buy any particular brand of hardware or make of hardware, and that is another advantage. And because of this distributed nature, you can go your nodes, keep on adding up to infinite level. We don't have any restrictions over there. And then the last one we discussed about, always when it is doing the replication, it does the rank aware replication, and that is the reason always Hadoop initiates minimum replication factor as a 3, and of course it is a configurable. And why it is 3? Because and whenever there is a the damage to your node, or like when there is outage on a particular node, and immediately it will look for replication of the same cluster on a different node, because that is very closest location to your node in the same cluster. And the second replication is on a different cluster on a different node. And the third one is a different rank, because all this is going to the data center. And in case you are looking for 4, if you have a different data center, then it is going to run a different data center. But if you don't have a like a data center for your fault tolerance purpose, or your the recovery purpose, then it is going to create one more block in another node in one of the other cluster or somewhere. All these calculations will be done by um, Hadoop itself. And also, in case you want to strictly follow this kind of replication, so mostly whenever you are adding a node to your HDFS, automatically it is going to find out what are these locations. Are they going to be same cluster? And depends on the IP addresses, and depending on the system addresses, it is going to group them. But in case if you want to specify, and we can also specify this information in a configuration wherever we are adding these IP addresses of all these nodes, we can group them. Like we can say this is a cluster 1, cluster 2, like this. And this information can be provided by us, or even it will also automatically take. But even though it takes automatically, we have to ensure that if you are administrator, we have to ensure that all these things are properly done, so that your replication will be done properly. That is all about the replication. So now this is all HDFS basics. And this HDFS only talks about the storage, and how the data is getting distributed. That's all. And to place the data, to process the data, and we have different mechanisms. Like further, we'll be practically learning some commands today. Okay, that's okay. And now, once you have your data stored, say for example, now we have all this data is stored. Let's say we have some nodes and blocks, everything. And from the architecture point of view, this is how your data point of view from the backend, how data is getting distributed stored. But when you look at the Hadoop overall ecosystem, and when you install Hadoop software, what are the software components are going to manage or monitor these particular activities? Okay, further, Hadoop always have a master slave architecture. So generally, we call it a client server architecture, but here the master means kind of a services, and the slave means kind of a worker nodes in a simple way. So this is the concept of only the file system. We spoke about only the file system. So now how these things manage, we'll see something about the architecture, then we'll move on to the MR processing, then I'll show practical, then we'll finish about the basic thing. And during this explanation, if you have any questions, please raise your voice, because I am not going very detailed, because I am making it compact for the data science purpose. So now, whenever, let's say I assume that we have 1, 2, 3, 4 nodes we have here, and then I am planning to install Hadoop software on this. And so of course, like basically in every machine we should have a HDFS software installed. Means the services must be installed, and maybe we can do it in a different ways. But when you install Hadoop software, what are the core components are going to be installed from the services point of view, and who is going to manage what? Okay, we'll see now. Whenever you install, when you are planning to install your Hadoop on like a one node or a two node or a three node, there are different ways of installation. But whatever way you choose it, the architecture will be like this. You need to identify one of the node as a master node. So always Hadoop, not only the core Apache Hadoop, or even if you take any distribution of Cloudera or Hortonworks or Mapper, all the technologies will be the same. So we need to identify one node as a master node, and this master node is going to have all these services, the core services related to manage the rest of all the services. So that is the reason one node must be selected as a master node. And then, so in this master node, we are going to install all these server related components. Okay, so just to give a more the detailed explanation, so in case you are planning to install, let's say because I am going here based on the Cloudera, so you can take Cloudera as a base, so that even other technologies also looks very similar. When you take, if you are planning to install Cloudera software on this particular node, let's say right now I have 4, of course you can future add any number of things. So first you need to identify one system has, the prerequisite is all your systems must be having your Unix or Linux installation ready. That is the prerequisite. Or in case you are planning with only Microsoft like Windows, and there are different, like Microsoft provides different plugins to, because generally HDFS and this Hadoop will not directly work on Windows operating system, and it always expects the Linux flavor. So in case you are still looking on Windows, Windows has some thing called Cygwin. Okay, this is a distributed flavor of whenever you install Cygwin, this is the interface. When you install it, will provide a shell capabilities, Unix shell capabilities on Windows machine. So in case we are looking on Windows, this is mandatory. So mostly if you go for Windows Hadoop, and they initially install all of them, and then you will get everything done over there. But typically I am not going on the Windows side, because that is not really proven. We are not going to use them in the industry side. And so in normal case, you can assume that like all the nodes or systems must be installed with Linux, and then you should have your basic stuff, whatever is required, network and all that. That is the first thing. And then you have to identify one of the system as a master node. And in that master node, especially when you are talking about the Cloudera, or if you are talking about, I generally call it a master node. But if you are looking from the Cloudera point of view, the Cloudera manager is going to be master node for us here. So Cloudera, all the main server services related components, whatever is required, so those servers or services related components are going to be installed on this particular node. If you are talking about the Cloudera, Cloudera manager is going to be the master node for us. So you can pick up any one now. So we will generally have a single master node out of all of them. And when you are planning to start your installation, and first you have to install Cloudera Manager. Or if you are going with core Hadoop, Apache Hadoop, and you need to identify a software which is going to manage other stuff over there. So better you take as a Cloudera. So assume that Cloudera Manager is going to be the master node here. So when you install Cloudera Manager here, what is going to happen? So this is going to control all your softwares which are going to be part of your node. So now when you are actually installing, this is a Cloudera Manager, means it's a manager is going to control all the rest of the other the client or slave services. Now, what are the major services we required in the HDFS or in Hadoop system? So HDFS is a file system, we already know it. And when it comes to data storage, as we know that when you place a block, always it is going to divide into blocks, and then every block is replicated and all that information. Say for example, now I have placed a file. The file name is like myfile.txt, and this is having 200 MB size, and I just placed over here, and it has a replication and all that. So the storage is fine. But say for example, now somebody came and then asking to access data whatever is there in the file. But actually, if I place a file on a Windows will know that this is the file name, it is available in this disk, and then immediately it will find out if the file name is not there, it will say file doesn't exist. If it is there, it will go and then access the data and then give you. It is all in one place. But in the case of HDFS, our data is not in one place, it is distributed. So first of all, we should know whether the file is present or not. And if the file is present, what are the how many number of blocks are split for this particular file, and what are the addresses of these blocks, and even when I am accessing these blocks, if one of the block is down or node is down, where should I go and search for the alternate replication? So all this information, if you don't have, then you are completely gone. So this is the reason to make this all information immediately available. In Hadoop we have two different services will be running. So one is called, let's say, wherever you are taking or treating your node as a master node, typically you can choose one service called name node. Name node is a service. What is name node means? It is whatever information you are going to place. For that particular information, the metadata is going to be stored on the name node. So always a name node manages metadata. So what is metadata? Metadata is nothing but data about data. So when you place a file, myfile.txt, and immediately the file is going to be initially going to enter, or this file name, only the file name is going to be placed or stored in a name node service. So this name node will be running as a master service in the node where you are. Even right now I have chosen this node as a master node, so that way my name node will be running on this particular system here itself. So whenever you place a file, first of all that file information will be entered into this particular name node. And also whenever you are storing because always like your Hadoop will divide them into blocks and all that, every block information, address of that block, and then replication of that blocks, all that information is going to be stored in the name node. So name node will not have any data. They have 200 MB of the data, but name node will not have the data. It is only going to store your file names and the block names and the replication names and all that stuff. So that way, whenever you are planning to access a particular file, say for example, I use a command to see data from a particular file. So immediately the request will go and check in the name node first whether this file name present here or not. And if the file name is present, it is going to immediately look for all the block addresses and then their replications. So then slowly your process will start reading the data from your actual data where it is placed. So this way, it is a two-way process. Your name node first, the first point of contact always will be with the name node, and that is your repository or metadata, and that information will tell you. Even when you are placing a file also, say for example I am going to place a file, and first your Hadoop will try to find out from the name node whether this file is already present in your name node or not. And then if it is not there, and then it will think about storing it. And if it is already there, then immediately it will say that your file already exists. And once your file is there, immediately it is not going to be placed data. It will calculate what is your total file size and how much block size I required and in which nodes we have empty. And then in case if there is no space available, and immediately it will going to throw us back, okay, saying that we don't have enough space on this one. So all these activities before going to store, the calculation will be done in conjunction with the name node, because your name node has all that information about your occupancy of the data on your nodes where we are going to store all this, and also what is that you are looking. All that information will be calculated in the first level of information only, where when before going to place it. For all of them we have a command. Those are called Hadoop distributed HDFS command. A couple of commands we can see practically. So overall name node is going to manage or store metadata. This will be running as a service. Typically we choose this to run on a particular master node. But even if you, let's say I am using Cloudera Manager here, ideally I will choose name node to be running on the same node. Okay, I'm just dragging because it is, I'm treating it as a master node. But even I have an option to choose it to run on different, any one of the nodes. I cannot have more than one. But from, if you see, like previously we discussed about Hadoop version 1, Hadoop version 2, currently we are talking about Hadoop version 3. So from Hadoop version 3 onwards, it is possible to have two name nodes parallelly running at a time. Okay, that I will talk about that later. That is a recent release concept actually. So this way, name node is always going to manage your metadata, and that can be running on any one particular system. Okay. And then all the other nodes where we are going to actually store only blocks, and those nodes are called data nodes. So all the nodes, these are all going to be your slaves. Yes? And to store your data, we need some services. Okay, because there should be some communication from your entire master to other nodes. But how does your master know that this node is our node? Let's say in your system, in your network there are 500 systems for there. But how does this node? How does this master know that? So they are all our nodes. So this is not our node. So in every node where you are planning to install, like your Hadoop, so on that HDFS is must, and then the data node service must be running over there. So yeah, everything, now every machine we must have a data node service running, and these are all comes under slave. So HDFS service and data node must be running on all the nodes here. So HDFS will distribute, and data node service will be coordinating with your master and all that, because that is how the communication happens. So this is the reason. Out of all the nodes, when you have 4 nodes, one of the node is name node, and the rest all the nodes are going to be the data nodes, and that can be, your data nodes can be infinite numbers, but the name node can be only one. And whenever you are storing or accessing first point of contact with the name node, and if you find out your names and all that, then it is going to pass that information. Then your process who is actually the reading, they are going to read the data from your respective data nodes. So data nodes are always worker nodes or slave nodes, and they are only going to store the data and use only for processing. So this way, in entire Hadoop system, your name node is going to be kind of a heart of your system. And but suddenly, in one of the case, if, let's say we have so many nodes, and if one of the data node is down, we have a data replication in another node, then I can access it. That's fine. But what if your name node itself is gone? Because name node is going to run as a service. So then your Hadoop is completely, means you will become a dead body. So this is the reason the name nodes has two things. One is one we can call as a primary name node, which is always will be active. And we can choose any one of the other node as a secondary. So there is a primary name node and then secondary name node. So always there will be only one name node will be active, and that will be the primary. And then the secondary name node which is there, always it will be getting the heartbeats from the primary name node, so the communication, and also on a regular interval. So secondary name node always will, primary name node will send the signal to the secondary name node, and then secondary name node will be keep receiving the signals from the primary name node to know that whether your primary is still alive or not. And also on a regular interval, so whatever data, metadata is going to be stored in the primary name node. So this is going to be synchronized with your secondary name node. So that way, always your primary name node, whatever you have, is going to be there in secondary name node in a continuous manner. So whenever your secondary name node is not able to get the signal from the primary name node, immediately it will identify, it knows that, okay, it will realize that your primary name node is down, dead. So then immediately this will become active. Then automatically your request will be sent to your secondary name node. So that is a continuous process in the system, and this is the reason your architecture is a master and slave architecture, and this is your master where you will have main services will be running, and the rest all are going to be slave, data. If your master node is down, then your Hadoop system is down. But if your data node, one of the data node is down, still I can manage my system because we have a replication order. So that is very high level, primary, secondary, and always only primary will be active, and there is no way. But from Hadoop 3 onwards, even we are making two primary nodes. Means there will be parallelly two primary nodes will be running, and if any one of the thing down, immediately without any latency, immediately we are going to get the data or communicate with the second, the replicated primary node. So this is the difference is that either this one will be active or this one will be active. From the latest version onwards, we can have both active running. So that is from the real time without no latency, and you will have your data processing will be done. So that is the reason. In Hadoop, whatever nodes we have, and we will call them as a, from the architecture point of view, primary name node and then secondary name node and then the data nodes. In all the data nodes, we must have a HDFS running, and then only you can have your data stored in a distributed manner. So HDFS also is one service, data node also is a service, and primary and secondary name nodes also a services. All will be running as a services only, and all they will be continuously controlled by your monitor. In case you are going by Cloudera, your Cloudera manager is going to take care of all these integrated, whether they are working fine or not, if any problem, or if you want to add any name node, data node, and your Cloudera manager will take care of adding them and also installing HDFS on that machine, installing data node service on that machine. Everything will be done by graphically through the Cloudera manager. And if you are administrator, you need to know all these things, otherwise not required. So, but overall here we have a name node, the primary name node, secondary, and then the data node. So these are the, as if you are talking about only storing the data in a Hadoop, you can just simply have, as long as you have a HDFS service, data node service, name node service running, then your Hadoop HDFS is there. So you can go and store the data. So this is all from the storage point of view. Now, from the processing point of view, so this is all talks about only. So far, it is all talking about storage only. So now here comes the processing. From the processing point of view, in a core Hadoop, there are so many processing technologies, but in the core Hadoop point of view, who is going to be process the data? MapReduce framework is going to be processed. So, because MapReduce is also going to be part of core Hadoop. When I say core Hadoop, your name node, data node, and then your MR processing framework is going to be the core Hadoop. Rest all are optional. I can or I may ignore them. But when I say core Hadoop, these things are mandatory. So from the MapReduce point of view, so why do we need a MapReduce? We have a data and then we can process it. Because when I keep a data in a Unix or a Windows, I can write a Java program and then simply process it. But why only this MapReduce framework is introduced? Why do we need a framework for this? So there are two things. One is like in your MapReduce framework, your framework is designed such a way that your program or whatever process you are doing, that process will be in line with your distributed processing. That is concept number one. And second concept is MapReduce data processing is designed based on or influenced by functional programming where your data mapper is something like extraction, reducer is something like a aggregation. Because in always data processing we need to read and then do some aggregation only. So it picked up the programming concepts by the functional programming, and it is mixed both distributed and functional programming together. That is our MapReduce framework here. And so to make this data processing happen and all that, so name node, data node, primary name node just will be running and then they look for storage, and then if somebody asks to view the data, they will give you that stuff. From the processing point of view, to take care of all of them, there are two different frameworks. And in the MapReduce 1.x version onwards, up to MapReduce MR 1.x version, here we have a couple of things. Okay, one, let's say I go and write a program in MapReduce using some Java, and to process your data, say now you write some program. Let's assume that you have written some program and you are given to process data one particular file, and then you submitted a job. To control that, in MapReduce or in a total core Hadoop system, we have something called job tracker. So this job tracker is going to be the parent or a master or headmaster of your job. That's when the moment when you say job, and the job how to start it, okay, and find out in which where is your name node, because when you are say process I want to read the data, first of all it should know that where is your name node, and find out how many number of blocks are there, where is the data, all that information to be controlled first, and that activity will be done by the job tracker. And once you have that information, then to really process the data, it is going to have task trackers who are actually process your task. So job tracker and task tracker. So these are the two critical things will be helping to process it. So they're all, and your job tracker is going to control all of them. So that way, when you look at the core Hadoop in the older version, we have name node, data node, job tracker and task tracker. These are the services will be running. And any job which you submit, and that will be controlled by your job tracker, that is from the MapReduce, and then your task tracker is going to control all of them. And then once the data result is completed, then the information will go back to job tracker, and even job tracker will manage how many tasks to be started, and how to control once the task is completed, map or reduce, so many things will be there internally, but a very high level job and task tracker, these are the two critical things from the data processing onwards. But actually, there was some lot of limitation in this concept in Hadoop 1.x flavor, the version release. The reason is like whenever it is processing the data, and this job tracker will manage the resources effectively related to that particular task only. But in case if there are so many other applications running, or like if the same operative jobs are running like 100 together, or in the same system there are some other technology stack tools like Spark or some Hive also running. So there will be so many things will be running, but this is untouchable to other the resources. That is the reason. As long as whatever job is submitted for that particular job, it is going to take control, but the rest all the things it is not going to control for us. So this is the reason. Means the resource management is not effective through this architecture. So this is the reason from Hadoop 2.x onwards, we have a different framework called Yarn framework. That is also known as MRV. Exclusively from the data processing point of view, the complete job tracker, there is no job tracker, there is no task tracker, completely gone from Hadoop 2.x version onward. So we have Yarn, that is yet another resource negotiator. The Yarn architecture, the resource management is completely broken up into different categories, out of which one is called resource manager. There is no job and task concept now, and we will have following services. One is the resource manager. So that is when I say whatever architecture I am talking, that is nothing but a Yarn architecture. So to any application, any activity, any process you do on a Hadoop, the complete application specific resource management is going to be done by resource manager, and that is again a master, and it can be running on any one of the node, master node typically. That is the reason we choose one system as a master and to control all your things. So this is the resource manager, and to process your data further, and we have a different now you can ignore this job and task trackers. That is the older version. Now this has become at your client level. We have something called container. And we have something called node manager. The node manager of how this particular, it is not a high level service. It is just to manage in this particular node what is the stuff happening. Then application master. So in Yarn architecture, it's completely revised. On every machine, yes, on every data node, and these things are going to be running as a services. So whenever you submit, this is all generally known as a Yarn architecture, and no task tracker, no job tracker. Now everything is only, even if you run any, people who have experience in MapReduce already, if you run a job, if you write a execute a MapReduce job in older version, you will see job tracker, task tracker. But in current version, if you run a MapReduce, you will see these node manager, app master, resource manager, and all that. So this is going to be take care of all the resources of your particular node, and all are going to be communicate with your resource manager, which is sitting on top of all these heads. So this is the Yarn architecture, and this whatever this box is there, and it is going to be run on all the machines. So now you can ignore them, and this is the only one now currently exists as well. So this is your core Hadoop architecture when somebody talks about. And why it is master slave? Mostly the mains are like the resource manager and like your the primary name node, and then all the master services are going to be run on this one particular node that is your master. And the rest all just worker nodes, slaves only, because they are just going to be. Even there is a damage or outage on a particular worker node, still there is no harm. But if there is a down time on your master node, so then your Hadoop system is going to be down. That is a big difference. Maybe for senior people, when talking about the high availability, if there is outage on any particular node, I don't have any problem. But there is outage on a master node, then it is going to be a problem. Means your Hadoop is down. So that is the reason in Cloudera Manager. So we will have a replication or disaster recovery for Cloudera Manager, because mostly senior architects will be asking me like from the high availability point of view. Hadoop architecture provides the high availability, because when the node is down, I don't have any problem. But if your master node is down, then your Hadoop is down, your system is down. So this is the reason we should have, or you must have a disaster recovery for your Cloudera Manager or your master node. The rest of things not required. How do you manage your disaster recovery depends on your distribution, and depending on what technology you are using, you can manage it. But we must have a disaster recovery for Hadoop Manager, your master node. So that is the reason this in the Hadoop, the limitation of MR2 or like Hadoop 2 was we don't have multiple name nodes running at a time. So now if I have two name nodes running parallelly, okay, my disaster recovery always will be managed perfectly, because parallelly I can have one more name node running in a separate system. If this is down, this is what we manage for us. So this is the core Hadoop architecture. If you ask me, like, there are so many things, Hive, Pig and all that. If I am not really not using Hive, I don't need. But minimum when you install Hadoop software, minimum these components are must. If you don't install Yarn, it is going to take MRV1, that's the job tracker task tracker. But name node, data node, and then your MR like job and task tracker, or at least Yarn. Any one of the thing is mandatory to process or to make data. That is your core Hadoop. The rest are Hive and your pigs. Scoop is optional. If I don't really need them, I don't really use at all. Say if I am using some data processing through Spark, I don't need a Hive or I don't need a, but I need minimum these things. These minimum components are mandatory for all the core Hadoop systems. So total the name node, primary, just to recap, secondary, data node, and from the yarn, because anyway now everything now we are with the yarn only. In the yarn architecture we have a resource manager. So this is yarn for map reduce processing purpose, and this is your core Hadoop distribution purpose. And typically whatever I am keeping as all these are going to be the master. So the rest all slave. So that is the reason Hadoop is a master slave architecture. That is a base platform for anything. Okay, so now we'll move on to some little bit of basic commands, and meanwhile if you have any questions, please let me know. Yeah, okay, fine. Any silly doubts also fine. Now I'll move on to the practical stuff. So are you following or like no questions means like are you able to follow or confusion anything? If everything is good, fine, I am fine. Or if you have any questions, let me know. Okay. So now when it comes to the practical, so this is our core Hadoop architecture, and when you are really planning to install all of these softwares, uh, one of the method, okay, you can use it, you can take your laptop and then you can install Apache Hadoop, because when it comes to the Hadoop software distributions, so one of the major distribution is the core distribution open source is Apache. But in case you want to go with the better versions, we can go with Cloudera and Hortonworks, Mapper, big insights, many more are there. So what is it? When you take any distribution, what is that you are going to extract only this part, because whatever master is there, and in that master they will give you one superior software called manager. Let's take example of Cloudera. Before going to install all this stuff, I will identify one machine and I will install Cloudera manager on that machine, and from there onwards, if you want to install any software like HDFS, data node or name node or MR framework or anything, all the softwares are going to be installed through Cloudera Manager. We don't need to. So your job is to do first installation of Cloudera Manager, and then you will get some graphical utilities, and from those utilities you are going to add any number of nodes you want to make part of this distribution, installing the software, deinstallation, decommissioning, and all that is going to be managed by the Cloudera manager. So that is the reason when you buy any distributed the different licensed distribution, and this is making our life easy, as they are going to provide the complete control through their utilities. And this Cloudera manager again will have their own repositories. So name node is a repository of Hadoop, but since how many number of nodes you are going to add in the system, how many you have in which machine, everything you can get, and the load balancing and the complete utilization, everything you can get in the form of charts and everything from the Cloudera manager. And for that, Cloudera Manager will also have its own repositories, and that you can use with Postgres, or means Cloudera Manager itself will have its own repository. This repository is nothing to do with the name node, data node, and to control all your softwares, it will have its own repository that we can choose either Postgres or MySQL. So now, when we are installing the software, one of the ways you can download complete software and then you can install and then you can start working. But it is not possible for you because mandatory is Linux, and if you have a laptop and getting all the stuff very tough. This is the reason. Um, Cloudera is providing a VMware version of installation. So they have uh, in single node they have installed Cloudera, and then they bundled into VMware, and then they are providing as a VMware. And if you want to download that VMware, you can just simply you need to just log in yourself and then you can register yourself. And then you can choose quick start for CDS. The recent version of Cloudera is 5.8, and you can choose a platform. There are different versions. VirtualBox is all are actually same, but this is VMware is the better one for us. VirtualBox is again similar to it is a close competitor to VMware. Now it is purchased by taken over by Oracle. So better you take the VMware version and then get it now. Maybe it will ask for the registration, and once you download, you will get a software like this. So once you have downloaded, once you click your this is the link where you can download it. The only thing is which I didn't do is I didn't log in actually. So once you log in, you will be getting. And what is that file you are going to download, or when you choose what is that is going to come into your machine is this. So when you download, this is the file you are going to get. So you just download it, and most probably the size will be approximately around 4.8 GB. So this is the file you are going to download. Once you download this, unzip. So you just take it and then unzip. And when you unzip, you are going to get a folder like this. And in this folder, you will see lot of files here. You can just unzip it. That's all. Then now the next step is you can now download VM player. That also you can search it from anywhere. VM player download, because I know everyone is master in googling it. And when you are downloading, choose which operating system. Let's say for example, check your Windows operating system or a 64 or a 34-bit, and try to download which is relevant for you. So download VMware. So mostly when you are looking searching for downloading VMware, right? You will see two versions. One is VMware player only or VMware workstation player. So VMware workstation player is a superior version, that in size and everything it will be very higher side. And if you want a lightweight, you can just simply search only for VMware player. Anything is fine, but try to take see now here VMware player only. This is VMware player only, and this is VMware workstation player. Both will work for us, and whichever comfortable you can just download it, and recent latest version you can download. Okay. See here, so VMware player 12. This is the file I have downloaded. When you download, you are going to get this. And then just to double click this file, you will get VMware installed on your machine. So when you finish it, it is going to install VMware player on your machine. If that is successful, you will see this icon on your machine, VMware workstation. So now I installed VMware workstation player because I had to do something. So VMware workstation player, well, this is the one I have installed. Now, once you have done, once you have completed this, the next task is to go to your Cloudera 5, the version which we have downloaded and unzip. And out of this entire folder, you will find out one file which is called VMware Virtual Machine Configuration File. This file. Maybe if you see the type, you can see that VMware Virtual Machine Configuration File. That is your. So mostly people will get confused here. So because everything is VMware only, one is VMXF file and this is VMFX file and these are all this file, but we are looking for this one. You will also see, you will also find the same name, but the type of the file is different. This is a disk file. So you have to look for machine configuration file. You just double click it and automatically your VMware player will be opened and then automatically you get into a system opened, like a window will be opening like this. And when you are doing this, maybe sometimes people may get some challenge over here. Sometimes when you double click and then immediately open, it will come and then immediately it will get disappeared. So that will be, for that some setting required. So in any of the machine, if you are not able to open, sometimes it will just open and then close immediately. So you have to enable virtual technology support in BIOS in your laptop or in your machine. Generally, in most of the new systems, this is getting disabled. When you are while you are logging to your laptop or a system, you need to go to BIOS and then you will find out one option virtual technology. And there, if it is disabled, you have to enable it. This is the one common challenge you will have in your machines. You can just Google it as per your make or a model of the laptop, and then it can help you to see how to set up and all that. If I want to show now, I need to reboot. So when I reboot, you cannot see it. So that is the reason. So when you open it, you will get a window like this, and within that window, the first what is that means VMware is nothing but it is going to open one more operating system in your machine without disturbing anything on our laptop. So now I have a Windows, but in that machine, it is opening another operating system on our system. So there are two operating systems running currently. One is see, this is Cloudera. This is Linux CentOS operating system. The Cloudera is not an operating system; it is just a name. You see Cloudera, but this is only a image to market their brand. That's all. But this is the actually Linux operating system, and this is our Windows. So there are two parallel operating systems running. And since both operating systems are going to run, in case you have 4 GB RAM of laptop or a system, maybe your system may be slow. So ideally, if you have at least 8 GB, then both will run perfectly. Say once you open, in case like if you want to allocate more, even you can also manage your the memory also. Once it is opened, if you go to player here and then if you want to manage your virtual machine settings, and this can be done before opening up Cloudera also. Here you can see memory. So what is the total memory available, and out of which how much you need to allocate for VMware. So now VMware means Linux, where Cloudera is running, and how much you want to allocate for this VMware. So now I have total 16 GB, and I am allocating 8 GB for this one and then 8 GB for windows. And processors also, how many you wanted, how many number of cores you are, like mine is I have 4 processors, so I am allocating 1 core to this particular process. So mostly processors and all you can leave it, but this memory, if you want to make your, if you have 8 GB by default, if it is not, if you have like more memory, if you want to increase or to speed up your Cloudera, you can increase the memory settings. So this way now your Cloudera is ready. So now this Cloudera is now installed on a single node, because this is only one single node. We don't have much. So that is the reason, from the architecture point of view, what we need to understand is, in this machine only, what are the things have a Cloudera manager, have a name node, have a secondary name node, have a data node. Everything is in single machine only. Means this machine has everything all in one. So this machine is a master and this machine also is slave, because we don't have other things. So done. We are like set up. Once you reach or able to open this, you are, means almost you have your Hadoop system ready. So mostly, if you are practicing, one of the ways, always this sits on top of Unix. So that is the reason we must have a very basic Unix commands to operate all your stuff. And mostly, ideally, I don't prefer exploring graphically. I always recommend, suggest you to always go with terminal only. So now, since being this as a Hadoop, if you come over here, you can click here. You can see a terminal here. So this is all Windows. And on this machine, to find out whether Hadoop is running, if you just type Hadoop, you are able to get some response like this. Means on this system already Hadoop is installed and running. If Hadoop is not installed on this machine, we will get command not found, this kind of error. So rather than we installing and doing, if you go with Cloudera VMware, you have a pre-built, pre-installed everything ready, so it will save a lot of your time. That is the reason always I recommend to go with the VMware only. Okay, fine. So now I can start to doing these commands over here. But ideally, maybe from a real-time, real implementation point of view, generally your servers will not be with us. Unfortunately, right now I have a server running on my machine only. I am able to open it. I am able to come here and then do it. But generally in a real time, your servers will not be with us. It will be somewhere else in US or somewhere, and you will not be having an opportunity to open your Cloudera system like this. So in a real time, everything on command basis only. So assume that right now we have Cloudera VMware or Cloudera server is here. Means Hadoop server is here. That's in US. And now have a laptop here. So currently in my laptop itself, the Hadoop is running, so I'm directly opening that machine and able to write some command. But in a real time, it is not the case. Your Hadoop server is somewhere, and then your laptop is here. And maybe here you may have a Cloudera, or it is using Apache distribution. I don't care. But from here, I want to access this. So you need to pick up. Let's say even in Hadoop, you can have n number of nodes, node 1, node 2, node 3. So ideally, you can pick up any one of the node, or you can pick up a master node, depends on your ability. They may share you either master or any particular normal node. The first thing is, we need to find out the IP address of this system where your Hadoop is running. That can be a master node or a data node. I can log into any one of the node and I can access everything. Like I can feel like you are sitting on Hadoop yourself. So I need this IP address, and I will connect to this Hadoop through putty using the IP address of this particular one. So that is the reason. Always here also I follow the same method. So assume that this is somewhere in US. I don't have access to open this kind of a GUI mode. So first of all, I need to find out this IP address where Hadoop is running. So I am going to terminal here. I am just typing a command ifconfig. It is similar to ipconfig in Windows. So this ifconfig will give you the IP address of this particular machine where your Hadoop is installed. This machine, not our machine. Our machine is different. Now this machine is different. And now you see currently what is the IP address associated to this particular Hadoop system. So 192.168.31.136. So you pick up, note it. Then now go back to your machine and try to download or search for a software by name Putty. So Putty is a lightweight interface to get connected. So right now this is purely a Windows, and from Putty I can go and connect it to any Linux. Right now this is a Linux machine and this is the Putty on Windows. And now I already given this information. You can just see. You can just come to the screen. Place your IP address, which I got it from there. Select the port number as 22. That can come easily by selecting SSH over here. Okay. And if you want to save this information, you can give some name here. Or if you don't save, every time you need to put this information. You can just quickly save here. And then click on open. So now from my Windows machine it is going and then connecting to Unix machine which is running. So no matter whether it is running on a my machine or on a different machine, I don't care. This is going to connect it to that. And means since I am connecting to another server, it will ask for the password. So by default, your username and password of your Cloudera is Cloudera only. So now you can just simply minimize it and then you can forget about this one. So now if you want to connect that, so similarly if I want to connect it to another Unix machine, say for example I have another machine running on a different machine, not another. Here I have only this one and I have another machine. Okay, so this is again, this username is like this. From my machine I can connect to n number of machine. Like this is in a completely in a different location. It is not in my machine at all. And of course this is on. So mostly currently because I am showing you because of the Cloudera, it is there and then showing you. But really, if your server is somewhere else, and I will be accessing to that this way. This is and this. So this is how we access the environment from your machine through Putty. So on these machines, now if I type it Hadoop, okay, Hadoop is running. So here how we access these basic Hadoop commands and what are the basic Unix required. Maybe that we'll see tomorrow. Maybe that is I can spend half an hour time and then I will finish Hadoop part. So I thought of completing today, maybe not sufficient now today. So another half an hour time I'll spend you how to access this Unix and then some basics HDFS command, and then I will put a full stop for it. Okay, so that's all for